First, let us discuss the code for the last week's lab assignment, and then we'll discuss for then we'll get into today's lab session, right? So yeah, so first let me show you the code for the server. Okay, so sorry, nano server.c. Okay, so what is expected is the client will request for a file, and the server should check whether the file is in the working directory or not. If the file is there, then the server should read the file content. First, the server should open the file, and then it should read the file content character by character or byte by byte, whatever it may be, and it should send to the client. And the content of the file should be displayed in the client. That is what is expected. So this socket creation, all these parts are similar to the normal client server socket programming, but the whatever the client sends, no, in that the first thing the client actually the client, when we execute the client, so how we execute the client here, I'll show you. So everything depends on that. So to execute the server, we use like this dot slash server, and then the port number, say 5600 means 5600. Okay, for executing the client we use like this dot slash client, then localhost, then the port number. After that we have to give a file name, some file, which file you want to display. So by default your working directory will be having these two code, at least client.c and server.c. Even you can request any one of this file, or if it is having any other files you can also ask for that. So say for example, um, say here in this working directory, say I give server.c, which means it will return server.c. You can give any file provided that file should be there, that's it. Okay, so this is how we execute the client. Now when you execute the client, we are what you call, we are using that command line arguments. These are command line arguments, this localhost 5600 server.c, all these are command line arguments. So the client program should extract all these command line arguments, and it should fetch that fourth argument. The fourth argument will be the name of the file that it is requesting. So the client should send this to the server first. Okay, when you execute the client should send this particular file name to the server. Upon receiving this, then server will check whether the file is there or not. If the file is there, the server will open the file, and then it will read the contents and it will send to the client. So that's the whole scenario. I'll try to maximize. terminal font. Yes. So here you can see there is no, this is not a while, there is no while here. This is for listening to the client. Server is listening for the client. Server is listening at this socket for the client. And then all these ports are similar to the normal client server program. See here we are saying read a new socket FD buffer comma 255. So basically this statement, if you see, this is accepting the client. This is accepting the client. The server is accepting the client. Now I'm showing you the server code. And now server is reading something. So what the server is reading? Now the client is not typing anything. But when you execute the client code, you are supposed to give the file name that it is requesting for. So that it is reading. So the client will be sending only that. And that is now read in the buffer. Right? This buffer can read maximum 255 characters, 256 characters. So that content is now available in the buffer. So if the read is successful, it will return some positive number. Suppose if it returns a negative number, then we check, then we say that there is some error in reading the socket. Right? Otherwise, it means it is successfully read. Then we try to open the file. So that file name. So now buffer contains the file name. So buffer contains the which file you want to access. That file name is available in buffer. So now from here onwards, it is normal file operation in C. We are opening the file, that particular file in read mode. So once it is opened, we are printing that file name. Suppose if FP is null, suppose if you are unable to open, then it means that that file does not exist. The client has given some random name. So if FP is null, which means either the file not exist or you have to say unable to exit and you have to quit. If this statement is not, if FP is not null, then it means some file exists. So we can read the data and we can send it to the client. So here we are using a do while loop, do ch equal to f getters. F getters is used to get certain number of characters. Okay. So how many characters we are reading? We are reading into buffer, right? So we are reading into buffer, and it will read up to 20 characters. It will read up to maximum 20 characters, but the buffer size is 256. But we are reading maximum 20 characters, and from where we are reading? From the file that is getting pointed by this pointer FP. So it reads 20 characters, and that read 20 characters will be stored in this buffer, right? Again, if this read is successful, uh, if this read is successful, yeah, if this read is successful, this will return some value. It won't return null. This f getters will return null when it has reached the end of file. Okay, the f getters will return null. So f getters will return either null or it will return some positive number. Suppose if it returns null, it means you have reached the end of file. So this if part will execute when you have reached end of file. If this is if ch is not equal to null, then it means that it's not an end of file. If it is not an end of file, then what we are doing, we are n2 equal to write new socket ft buffer comma string length of buffer. That is whatever we have read, that we are passing to the client. That's what this statement does. Whatever we have read from the buffer, you are sending to the client through this particular socket. We are writing to this socket. Whatever we have read, we are writing to this socket. Which content we are writing? The content that is available in the buffer. And what is the length of that? That we are getting by using this function string length of buffer, right? So whatever you write into this buffer, it will automatically go to the client. So that's the whole concept. Suppose if this is null, it means you have reached the end of file. But still, uh, but then also you have to send the content to the client. Why, you may ask? Say, because here we are reading 20 characters. Say for example, I have read 10 characters. Say for example, uh, if uof occurs, if uof occurs after reading 10 characters, then what happens? Then that 10 characters should be sent to the client, right? You cannot avoid those 10 characters. So that is the reason within this if condition also we are writing this statement n2 equal to write, that is whatever in the buffer, write it to the socket, even if it is uof, because we don't know when uof occurred, whether uof occurred at the first character or second character, or uof occurred after reading 19 characters, because here we are trying to read maximum 20 characters, right? So that's the reason inside this also we are writing this statement. Okay, so that's the whole story. Actually here you can write else, otherwise this will write for, this will execute for two times, this n2, right? So this do while loop, how long it executes? Until ch becomes null. So as long as ch is not null, it will be keep executing. Then finally we are returning 0. So this is the code for the client. So the only extra thing is this loop. That's all. This loop is the extra thing. And in the normal client server program, client is expected to send something. Hi, welcome, hello, whatever it may be. But instead of that, here client is not sending anything. But when you execute the client, the part of the execution itself includes the command line argument, which contains the name of the file it would like to read. So that file name will be sent from the client program. That code will be read, should be included in the client. So whatever here we are getting from the client is nothing but the file that is to be read. Then we are opening the file in the read mode, and we are running this do while loop. Right. So this is about the server code. So coming to client code. Okay. I have actually executed this in the laptop, and then I copied this program here. I think so that this error is coming. Fine. Hmm. Yeah. So this is the client code. So this is the, what do you call? This is the method to execute the client. /client localhost, the port number, and the file name. So whichever the file you want to read, that file name. So again, if you see the usage of the part of client is very same. Actually, client is very similar to that of the simple client server program which we have discussed. Only thing here it should accept how many arguments. Here it should the number of argument count. The argument count should be 3. Argument count. Yeah, argument count should be 4. Here argument count should be 4, not 3. In the simple client server, it is 3. Here 1, 2, 3, 4. Okay. So if it is less than 4, then you can stop. So you can say that usage is percentage yes. Usage is percentage. I mean, percentage yes. Yes is nothing but the client file name, right? Host name, port number, followed by the file name. At last, you have to give the file name, right? So it should take 4 arguments. So this dot client, that is nothing but argument 0. Localhost is argument 1. This port number is argument 2, and the file name is argument 3. Right? So argument 3 we have to fetch. Argument 3 we have to fetch, and that contains the file name that is to be the name of the file that we want. Okay. So that is actually a 4th argument, but array is indexed from 0. So when you index from 0, that becomes the 3rd argument, 0, 1, 2, 3. So that 3rd argument, we are, see here, we are taking the 3rd argument as it is, argument v of 3, and length of that we get by string length of argument v of 3. and pass that to the socket. So here we have socket FD. So up to this, the code is same as that of the simple client server, right? In the simple client server, here we ask the user to type something, and the user, see, this is the code I have commented here. In the simple client server, this is what we do. We ask the user to enter the message, and we read the message. That message we will send to the server. But instead, here what we are doing, we are not asking the user to enter any message. Rather, whatever the argument 3, that is the actual argument 4, which contains the file to be accessed, that argument we are writing to the socket. So we are writing it from the client, so obviously it will go to the server. If this write is successful, it will return some value greater than 0, otherwise it will return less than 0. If it returns less than 0, then we say that error. Right? So this is just to empty the buffer. Already we have returned the content, so again we are sorry, here we have not used buffer here. Here we are emptying the buffer. Now what we should do, now the server will be keep on sending the file content. We don't know the length of the file. The length of the file, maybe it may have 5 characters or 50 characters or 500 characters or 5000 characters, we don't know. So the server will be keep on sending, we should keep on receive, and we should display it, right? So how do we know when, what you call, when to stop? So how do we know when to stop? So whatever we read it in buffer. Okay, so for that we are using this buffer, so that buffer is, initially we are making the clearing the buffer to 0. Buffer is nothing but a character array of size 256. We are using another variable. I think we are not using this is not required. This statement is not required. I will comment it. Now we are reading from the socket. Read socket FD buffer comma 20. Again we are reading in the buffer 20 characters at a time. If this read is successful, it will return 0. Sorry, it will return some positive number. Otherwise, it will return some negative number. So as long as the read is successful, while n greater than 0, whatever we are reading, we are displaying it. Whatever we are reading, we are displaying it. Again, we are making the buffer to 0. We are emptying the buffer, and once again we are reading. So we are keep on doing this. How long you will do? Until the read is, as long as the read is successful. When the read becomes unsuccessful, the n will return. I mean, this read function will return some negative value. So n will not have a positive number. It will have either 0 or negative number. Right? So once this is over, then after coming out, we are displaying this outside while buffer. Okay. The reason is, as I have said already, sometimes, what you call, sometimes UIF may reach after reading few characters. So in that case, the last some of the characters may be missed out, so that if anything else in the buffer to print that, we are using this statement. So that's it about the client and the server code. Let me execute it. So let me see what are the other files. So here, so this is the program we are going to discuss in today's class, shell_lab.c. Okay, so I'll try to execute with this. So this directory contains these files. First, let me run the server. Server is running. I'm opening another window. So CCC client.c -o client. So now let me execute the client dot slash client localhost. You can also try in two different systems. In that case, instead of localhost, we have to give the IP address, port number. So I'll give that particular program, that is shell hyphen lab.c. Okay, so it is basically reading that file and it is displaying as it is. Right. So it can be any file. It need not be a program. It can be a text file also. Here there is a text file history.txt. I'll use that now. Okay. So server has came out. So once again, let me execute the server. Okay. So that's it about the last week's lab assignment. Now let us get into today's lab program. So the lab program that we are going to discuss in this session is actually you are expected to implement an micro shell. Okay, so it is to implement micro shell. I'll be giving you the partial code. So what is a micro shell? Micro shell means you have to create this type of Linux environment, this type of Linux terminal. So in a Linux terminal, we can execute several commands like ls-l. We can make create directory. So to create directory, make directory, say some directory. So now this will create a directory with the name some directory. So then I can change to that particular directory. So like that, Linux supports hundreds of commands, right? So you are going to create an shell environment where we'll be at least able to execute some 6 7 commands, right? We cannot implement all the commands. So you can later, out of your own interest, you can develop the shell to support all the commands also. But now we'll be implementing some 6 to 7 commands, right? So basically it is to create an what you call a micro shell environment, a small shell environment, so or a small terminal kind of environment. So that's the whole objective. So let me get into the code. Operation not permitted. So this is the code. See here, some of the functions I have not implemented. So those functions you have to implement. I have left it open, right? So these are the commands we are going to implement in this micro shell. The first command is ls. Ls will just display all the files and the directories that are in the current directory. And then ls hyphen l. So this second command is this. So this function will be called when you give the command ls in the micro shell. And this function will be called when you give the command ls hyphen l in the micro shell. Actually, the command is ls hyphen l. You should give us ls hyphen l. But the function I cannot give include hyphen, so I have used underscore, right? And this function is used to clear the screen here, and this function is to quit from the terminal or from the micro shell. And this function make directory, this is used to create a new directory. And this function cd, it is used to change to the to some other directory. And this function env, it will display the environmental parameters. So every operating system will have some set of environmental parameters. Like when you install the software, these environmental parameters will be set with some initial values. So env, it's a command, you can check it out in Linux. It will display some environmental parameters. So whatever that environmental parameters, it should be displayed. And rmd, uh, it is for removing the directory, deleting the directory. pwd, it is to print the working directory, what is the current directory, right? And history, if you give just history, it will show the last 60 commands that you have used in the terminal. What are the last 60 commands you have used in the terminal? So that is how history command works. So there are two ways of usage. You can use just history, or you can give history space some number. In that case, it will display the recent. If you give history space 5, it will display the recent 5 commands that you have executed. So I'll show you. Say for example, I'm giving here history. These are the previous commands I have used. So it is showing 33 commands. Okay. So maximum, I think it will show up to 60. If I give history 2, it will give the last 2 commands. So you can see here the last 2 commands. If you see, this is the last command. History 2 itself is the last command, and the previous command is history. So, or say if I give last 5 commands, then history 5 is the recent command, and then history 2, and then history, and then this nanoshell underscore lab.c. So you can check here. Based on this, it will come, right? So yeah, so that is the purpose of history command. Okay. So now getting into the code. So again, this program also, it should take command line arguments, because why it should take command line arguments? Because here all input is nothing but inputs are received as command line arguments only. Whatever the input we give, it is initially it is basically it's a command line argument. Okay. So I will show you also the env. So when you give env, you will get like this. So this is the environmental parameters. It may not make sense for you, but see, whenever you install any software, some env is a file, or it can be, or it's not a file, it's a parameter, it's a set of parameters. So when you install any software or anything, the appropriate env parameters will be set up with some values. It's just the content of that, that's it, right? So when you in your micro shell also, when you give env, you should get this output. So that's the whole objective. Okay. Fine. So here, sorry, here we are not using, here why we are using command line arguments, you may ask. Here we are using command line arguments only for this command env. We have to use the command env. If you want to use the command env, then normally in the command line arguments in the previous program you have seen, we have used only two two variables in the main function. One is argc, which contains the argument count, number of arguments, and the other one is argv, which contains the list of arguments as a what you call array of string, or it's a pointer to character arrays. Here we are using also a third parameter, which is nothing but envp. This envp will hold all the environmental parameters. This envp will contain all the environmental parameters. So if the user gives the command env, you need not do anything. You have to just display this content, nothing else. So already it will be available in envp. Is that clear? When the user gives the command env, which is to display the environmental parameters, you need not do anything. You have to just display it. You have to just run a for loop and display the content of this uh, what you call array of pointers, right? That is what is expected. And to capture that, we are using here command line argument. Otherwise, for this program, command line argument is not required. Fine. So here we are creating a character array. The name of the character array is buffer. Its maximum size is this. It is based on this file name max. So I think this file name max is some predefined constant. It can take some values. Otherwise, you can also give some directly some value here. Not an issue. And then we are creating a pointer to character which is CMD. Using this only we are going to receive the commands from the user. So the commands received will be a string. So we are using a character pointer for that. So so CMD equal to character star CLOG 100 comma size of character. So for this command, so this is a character pointer. For this we are allocating 100 bytes of memory. So this pointer is now pointing to 100 bytes of memory, and this memory is allocated using CLOG. Why are we using CLOG? Why not we use malloc? You can use malloc also. We are using CLOG because we want to clear that content to 0. When you use CLOG, the memory will be created and also it will be cleared to 0. So that we are using CLOG here. So it means that it can receive a command with maximum of 100 characters, not beyond that. Now we are running an what you call and in an unending while loop. So it's this while loop will never end. While one we are saying, so it's an infinite loop. Then we are seeing get CWD. Okay, actually this get CWD, why we are using get CWD is a what you call it is a system call, or you can say it's a API. Get CWD is a API which will call the system call corresponding to the current working directory. It will call the system call corresponding to the current working directory. Why we want, so this particular function will return the current working directory. What is the current working directory? That working directory it will give with the entire path. What is the home directory? What is the subdirectory? Where you are currently? Everything this function will return. So it will be returned in the first parameter. The first parameter is a character array. It will come here, and maximum it can take this many characters. So that is given in this particular string, which is a predefined context in a constant in C. Maybe it may have some values like 1000 or 1050, something like that, right? Okay. Now you may ask why we want this. Any idea? Anybody can say why are we doing this? Why are we doing this get CWD? It will return the current working directory, but why are we getting that? Not ls or n. I'm not see before ls you think. When you think of an microkernel, when you think of a kernel, what is the first thing you will see in the kernel? What it will display? Not kernel, terminal or a shell. When you see a shell or a terminal, what's the first thing you will see? In which directory we are? Yeah, good. Parameshwar, go. Parameshwar, Goga. That's correct, exactly. So first we want to display that. See, there is another window I have opened. I'll see here. You see, what is this? This is nothing but my current working directory. This is the prompt. So when you create a micro shell, also first I want a prompt. So this is the prompt. In the prompt only, the user is going to enter the commands. So how will I get this? So first in the terminal, I should display this. Then user will give the command, we will receive the command. Okay. So that is the reason we are using this. So this get CWD will get the current working directory, and that is available now in buffer. Now we got the working directory, but now after that we are printing it. Print of \n percentage yes, this buffer. So whatever is in buffer, it is the current working directory along with the full path from the home directory to the current directory with slash everything it will come. Okay. So after displaying the directory name, we are giving this greater than symbol, or you can also give dollar. That is up to you. See here in this prompt, dollar is coming. Some cases greater than symbol will be there, or so that's basically it's not an issue. Any symbol you can give here. So to represent that it is a prompt, I have given this greater than symbol, or you can also give dollar. So this will basically provide a Linux shell feel. Okay, fine. Now we are ready to receive commands from the user. So to receive the commands, we are using fgetters. Again, you may ask why we are using fgetters. You can also use scanf. We can also use scanf, but when you use scanf, you cannot read inputs with space. Scanf will not accept input with space. If you give space, then it will be treated as a second string. But some of the commands, no, you have to give spaces. Say for example, ls-l. So there is a space ls space -l, or if you history space 5. All these are like that. There are many commands. Okay, even there are commands with more than what you call more than 3 strings or 4 strings. So we should accept space, uh, so that we are using fgetters instead of scanf. Okay, so fgetters is also just to read something from the terminal or from the console. It's as simple as that. So whatever we read from the terminal, so now whatever the user types, we can read it from the terminal, and that will be stored in this variable cmd. What is cmd? Cmd is this character pointer to a character, and we have allocated 100 bytes of memory for cmd, right? Okay, so maximum how much it can read? 100. Why 100? Because we have allocated only 100 bytes for cmd. And from where it should read? From stdin, that is from the standard input device. Okay, fine. Now see here, the moment we read that particular, no, this is a command we have read. User has given some command. We want to now figure out like how to execute this command. But before going to that execution part, whatever the command he has given, we are sending it to a function called history file. We are sending it to a function called history file. I'll show you this function later. Okay, but what it does in the sense, whatever the command will be stored in a particular file. Command will be stored in a file called history.txt. So we are going to maintain a file called history.txt. We are going to create a file called history.txt if the file does not exist. So this function will take care of that. This function history file will first check whether the current working directory is having a file with the name history.txt or not. If such a file exists, it will open the file. It will open the file in append mode. Append means the existing content of the file will not be removed, but to the end of the file, it will add the new command, whatever the new command the user has given. Right? Okay. So could someone guess why are we doing this? 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 So when a user gives a command, no, before executing the command, we are writing the command to a file called history.txt. Any idea why we are doing this? Any guess? Yeah, for getting the previous commands which we execute. Okay, but yeah, but we are not implementing anything for executing the previous commands. For history command, yes, Orion, that's correct. For history command, because one of the command which we want to implement is history command. So how will you implement history command? So whatever user types, you just dump into this file. And if again, if user gives the what you call gives the command history, just read the history.txt and display it. Okay. If user gives history space 5, that you have to think. But I'll give you a hint how to do that. So that's the reason why we are doing this, right? Fine. Okay. So 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 that is fine. And then here, if suppose if the command given by the user is, here we are using, so this is a C function, string str n compare. These are functions available in C. These functions are available in the header file string.h. We are including string.h. This header file contains a one interesting function called strncmp, which will compare two strings. It will compare two strings. So the string in CMD, it will be compared with this string. So if the string in CMD is equal to env, then it will return 0. You may ask, what is this 3? Which means that just you compare only the first 3 characters. So from CMD, we are saying that you compare only the first 3 characters, nothing beyond that. Okay, so that this 3. So it takes only the 3 characters. So if the first 3 characters, whatever in CMD is equal to env, uh, then it means that the user has given the command env. If the user has given the command env, then what we are doing, then we are calling the function env. Env is a user defined function, and we are passing this envp. What is envp? You recall, envp is nothing but this command line argument, one of the parameter of the command line argument, which is a what you call, it is an array of character pointers. So each of this pointer will point to the set of environment variables. So this envp we are passing to this function env. So this function is supposed to read this content of this array one by one, and it should display it. That's it. Okay. So this is basically the implementation for env, or I can say it is a partial implementation of for env. Okay. So only for env command I have given here, but for other commands, to parse other commands, I have written a separate function called parse. You may ask, why for this alone it is here? Because this is main function. In main function itself we have envp. Okay, so this is a special command. Otherwise, again we have to pass envp, which is not required for other commands. Are you getting? So that is the reason why I have for env alone I have written here separately. If it is any other command other than env, then that will be identified by this function parse. So parse is the function which is used to identify which command the user has typed and to call the appropriate function. So that will be taken care by this parse function. So here we have the parse function. So here we are pausing the command and we are receiving this also as command. So I'm using here same variable because actually they are local variable. See, this command is local only within the main function. It is available only within the main function. And here this command is available only within the parse function. So I have given the same name. If you feel confusing, you can give different names also. Right? So now this parse function should identify what command the user has given. Suppose if the user has given the command ls, then again we are using string, what you call, string n compare command comma ls, command comma ls, string length of cmd minus 1. Why are we doing this? See, when the user gives the command no, normally when the user gives command, how he will give, user will give like this, say ls, then user will press enter. Okay, but ls, but this enter is equal to backslash n. Actually ls is that enter is equal to backslash n. So if you apply string length for this, if you apply string length of ls backslash n, so actually the string includes the backslash n also. String includes the backslash n also. So when you apply string length of ls backslash n, actually the string length function will return 3. Are you getting? String length function will return 3. But actually the number of characters is only 2. So how to get that? So string length of the particular command minus 1 we should do, then we will get the actual length, right? So that is what here we are doing. So for every command, uh, actually the command contains so many characters. But after typing the command, the user will press enter. So enter is nothing but backslash n. So when we calculate the string length, that backslash n should be removed. That's what we are doing here. String length of command -1. So after subtracting the length of the string with -1, we check whether it is equal to 0. So it will be equal to 0 if this command is ls. Otherwise, it won't be 0. In that case, we are calling the function ls. Okay. Else if, similarly, else if the command is this, okay, that is what cmd contains. If cmd contains ls hyphen l, and so here length, why we are doing length means we are comparing only that many. In this case, we will compare only first two characters ls, because we need not compare backslash n. Okay. And here also I'm not giving backslash n. So here also we want to, we know, we should, here we will compare only 1 2 3 4 5 characters. This space also included as one character. Okay. So this basically this will return here this string length, this thing, no, it will return here 5, which says that you compare only the first 5 characters in cmd. So the first 5 characters in cmd, if the user has given ls hyphen l, it will be ls space hyphen l, right? So if it matches, then it will be 0. Then in that case, we call this function ls underscore l, on and so forth. This is to check whether the command is clear, then call the clear function. If the command is quit, call quit. If the command is mkdir, call mkdir. Okay, here another important thing you should see. When you call mkdir, see here again we are passing the command as an argument. Why? Because actually mkdir is a different kind of command. It's not a one line command. Mkdir, then you may give some directory name, the new directory that you want to create. So mkdir os1 means later we want to create a directory with the name os1. Okay. So this function needs this entire thing, right? Because which name the directory should be created, accordingly you should create, so that we are passing the entire command also there. So that function will take care how to identify the directory name, all those things. Similarly, cd, so this is for changing the directory. Again, for changing the directory also, we are not just calling the function, but we are passing the entire command as a parameter, because here also we give cd new directory os1 or os2. So so this function is expected to write the command to change the directory. Then you should know to which directory it should change. So that is available in cmd. Okay. Here also I can extract this os1 alone and I can pass, but then this code will become clumsy, right? I don't want to do that here, because this function I thought of using only for parsing the command, which command is for what, and to keep a separate function for each of that, right? Similarly, this is for rmdir, that is to remove the directory. Okay, so again we are calling the function rmd, and we are passing this command. Okay, and this is to print the current working directory. This is here we are just calling pwd. This is used to print the current working directory, and this is for history. Again, history also there are different two ways of usage. One is you can use history just like this, or you can use like this also. So this function should first differentiate what type of history the user has given. Okay. So if this command uh, has contained only what you call only history, then its length will be only 8. Okay. If the user has given history, just history, then its length will be only 8. 8 including the backslash n. If it is more than 8, then it means that the user has given the command in this style. So this function should differentiate between the two, and accordingly it should operate. Right? If any other command, then we are saying invalid Unix command, or you can give some special name for this kernel or for this shell, and you can say that it is an invalid command in this new operating system. Okay. So you can add more commands to this, and you can create your own OS also. Fine. So this is the code for the history file. You could have recollect here. Here every command the user gives, that we are passing to this function history underscore file. So that function, what it does, it just receives the particular command, the entire command as a parameter through a pointer, through a character pointer. Okay. Now we are opening this file fp fopen history.txt in append mode. If the file does not exist, this command will create the file also. If it exists, then it will open in the append mode. Okay. Then we check if fp is null. If fp is null, then there is some error. So we are displaying there is error and we exit. Otherwise, if fp is not null, okay, then just whatever the command you read, just write onto the file. It's as simple as that. So we are just doing f print of fp, where we want to write the where to this file which is pointed by fp. What you want to write? A string. And where is that string? It is in cmd. So f print of fp percentage s cmd, f close of fp. So now all the commands we give, it will be in this file, right? Okay. So here is the code for ls. Yeah, here is the code for ls. There is a structure called die rent, directory entry. This for this structure we are creating a pointer star d. Actually, using this structure, you can collect all the details of a working directory in Linux. So this is a predefined structure. It's not a it's a predefined structure. For this structure, we are creating the variable star d. Now, similarly, there is also what you call uh, an object or variable of kind dir. For dir, we are creating a pointer dir. Dir equal to open directory of dot. Dot represents the current directory. Okay? Dot represents the current directory always. So you may be knowing, I guess, dot refers to current directory, and double dot refers to previous directory, right? Or you can also give here any directory name. If you want to fetch the content of a particular directory, you can give here that name. But ls should give the content of the current directory. So that here we are giving dot. Okay. So when you give this no, basically you are creating a pointer. This pointer dir will point to all the content of the directory which is specified here. So here now it is dot, which is nothing but the current directory. So all the content of the current directory are being pointed by dir. So we check whether dir is null or not. If dir is null, then we say that there is something error in opening the directory and we exit. Otherwise you just read the content of the directory and display it. So we are using this while loop, while de. So de is a structure variable. De equal to read dir. Then this is a predefined function of dir. So you keep reading how long you should read until it's not equal to null. As long as it is not equal to null, this is a structure, as I said already. This structure contains several things, but this ls will not display all the thing. Ls will display only the name. Ls will display only the name of the particular directory or the file. So from this structure de, from this structure de, we are displaying only name. So de underscore de arrow d underscore name. Only that we are displaying. So I'll show you the structure format. So structure. Yes, see, this is the structure. It contains dino, which is something called as inode number, d of offset, length of the particular uh, record or the file name, d type. Okay. So like that, it contains so many fields. So actually you should use the other fields also. The other fields also will be usable, especially for ls -l. So but for ls, ls will give only the directory name or the file name, so we are using only d name. Okay, now ls hyphen l, I'm not implementing, so you have to implement it. Okay, actually ls, this is challenging. You may have to refer so many things to implement ls hyphen l, because when you implement, see here you can see when I give ls hyphen l, I'll give one more time ls, or say here when you give ls hyphen l, you can see this d represents directory. Okay, so which means that this ch1 is a directory, so it is coming here d. If it is a file, it will be a hyphen. So this client is a file, it's a object code. Client.c is a file, so that here it's a hyphen is coming. Okay, then rwx, see the first rwx represents the owner of this file, or the user who created this file, what access he has. He has read access, write access, and execute access. That is what the first rwx says. The second one says the group access. If any group, so some group will have rights on that, so that group can only read and execute, they cannot write. So that's what write hyphen x. And others, what about others? Other than the owner and the group, they can only read and execute, they cannot write. So these informations you have to display. How will you get this information? That you have to refer Google and do so many things. Okay, and this represents the linkage, hard link. This one represents hard link. Normally the hard link for a file is one only, but in some cases it may be more than one. Basically hard link refers like how many pointers are referring to this particular directory or file. By default there will be only one pointer. Okay, so there is only one reference to this, but in some rare cases there can be two reference. Okay, so what is meant by two reference, you may ask. See, this is something like this. Say for example, there is a file, say abc.txt. Okay, so this is just a name, right? This is a name. So this abc.txt, say it refers to a particular physical file. So it refers to some file which is stored in hard disk or memory somewhere, right? Now say that there is another name xyz.txt. Say xyz.txt also refers to this same file. I mean, these both files are same. This file and this file is same. In that case, we say that for this particular file, the hard link count is 2. Okay, which means this is something like an alias. The name is 2, but they both are referring to a same file, right? So that's the whole concept. So in this case, what does it mean in the sense abc.txt and xy.txt, they both are referring to a same file. If that is the case, the hard link of that will be 2. If there are 3 such files referring to a same file, then their hard link will be 3, right? But generally that will not happen, so that you can see the hard link value is 1. And the next represents the user or the owner of this particular folder or file, and the next represents the group user. The here this is the username, this is the group name, and the next is others. If anybody else can access, what is their name? Nobody else can access this, so nothing is here, so there is a space. And this represents the size of this particular file or directory in bytes. So it is 4096 bytes, and the rest of the thing represents the created date, month, and time. So it's created on September 12 at this particular time, right? So this you have to do. Okay, fine. So here I am showing you the code for make directory. So this is for make directory. So cmd contains what? Cmd contains, say for example, Yeah, CMD contains MKDA or the directory you want to create. So if you want to create a directory test001, then CMD contains all these things. It contains the MKDA or command also it contains, and apart from that, it also contains space which directory to be created. Now, first we have to extract this test001 separately. So what we are going to do that, and how we are going to create the directory, let us see here. So this we are creating a character pointer p, an integer I. Initially p is set to null. We are checking the length of the command. What's the length of this command? So, so in this case, if you see the length, it will be 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Including backslash n, it is 14. So the length we are calculating, and we are allocating some memory for this pointer p. Okay. See, after calculating the length, see what we are doing. As I have already said, we need to extract only this test001 part. We have to ignore this mkdir and space. We have to ignore this mkdir and space. So here we are running a for loop. For I is equal to 1, I less than or equal to 6, I plus plus. Why 6? Because because the length of mkdir is 5, including this space it is 6. Currently cmd is pointing here. Cmd is a pointer. Basically it's a pointer. Currently cmd is pointing here, but we want to make it to point to here, to t, right? If it is pointing to t, then it means that we are having that string in our hand. So if you want to point cmd to here, then this pointer should be incremented 6 times. When you increment for 1 time, it will point to k, 2 times d, 3 times I, 4 times or, 5 times this space, 6th time it will point to t. So that is the reason here we are running this for loop for 6 times. For I equal to 1, I less than or equal to 6, I plus plus, cmd plus plus. So once this for loop is done, now cmd is pointing to only this e, and followed by that the particular uh, directory name to be created. Okay, fine. Now what we are doing, string n copy. See, this is not compare, this is copy. This is to copy the content of one string to another string. So I'll show you again string copy. So this is the syntax of string n copy. So basically this will return a character pointer. This function will return a character pointer, and what are the arguments it takes? The first argument is destination. This is not the source, this is the destination. The second one is the source, and the third one represents how many characters you want to copy. Okay, so this many characters, n characters, will be copied from this string to this string. N characters will be copied from source string to destination string. The second string is the source, so n characters will be copied from the second string to the first string. That's what this function does. So here we are saying that, so you can see this pointer p is null. P is null. I mean, initially it was null, but currently it is pointing to some memory location with 50 bytes, and it is cleared to 0. So what we are doing here, string n copy p comma cmd comma length minus 7. So why are we doing this again? Length contains, so length contains what? Length contains the length of this entire string. Length contains the length of this entire string. From the length we are subtracting 7. Okay, so if you subtract 7, what you will get? See, currently, see, let us calculate this. This is uh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Including backslash n, it is 14. Okay, his length is 14, right? And length minus 7 means then you get 7. Okay, so basically this length minus 7, actually it contains 7, right? Now we are saying that CMD, from CMD we want to copy something to P, but we are going to copy only first 7 characters, right? And currently what CMD contains, as of now, CMD is pointing to, it's not pointing to the full command, it is pointing to this much, test 001. It's pointing to test 001, and also there is a backslash n. Okay, and also there is a backslash n. So so we are saying that it will copy only 7 characters. So you count 1, 2, 3, 4, 5, 6, 7, right? We want to ignore this backslash n. We want to ignore this backslash n, so that we are doing this length minus 7. I guess you are following, right? Because whatever the total length, from the total length, we want to ignore this first 6 characters, right? This first 6, for ignoring this first 6 characters, we incremented CMD plus plus. That is fine, but the last backslash n also to be removed, so that here we are doing length minus 7. Okay, or you can use any other trick also to remove that backslash n. So basically we want this test 001 alone to P. For that we are doing this, right? Okay, then And actually, for creating MKD, creating a directory is very simple. There is a function called mkdir. There is a function called mkdir. You have to just call that function mkdir, and P, the character pointer, should contain the name of the, what you call, the directory you want to create. I mean, this pointer should point to the name of the directory you want to create. So mkdir p comma 0777. This is some code you should give. So this statement will create the a directory, right? And it will return some positive number if the directory is created successfully. And if there is some issue in creating the directory, then it will return -1. Suppose if it returns -1, then we say that there is some error or invalid command, and we come out. Otherwise, we say that the directory is created successfully. So this is the logic for creating a directory. Actually, it's very simple. Only this function we have to use, and P is a character pointer. It should point to the directory. It should point to the name of the directory that is to be created, right? So that's it about creating a directory. Now changing the directory, if you see, changing the directory is very similar to create the directory. Instead of mkdir, here some other command should be given that you have to search and find out. That implementation I have not given. So this is removing the directory. So see, changing the directory and removing the directory, all these are similar to this creating the directory. Okay, so one example I have given. Remaining you can explore. Clear. Actually, clear I have implemented. There is no other way to implement. This is the only way to implement clear. So I am using system clear. Okay, but you should not use system for implementing anything. Okay, so here I am saying you should not use system to implement anything. Okay, because this is something like a hack. This is something like a hack. Any Unix command can be executed by calling the system function. Any Unix command can be executed by calling the system function. So only for clear you can use system. I have already given in the code. Apart from this, for no for any command, system is not allowed. Okay, say for example, uh, I can directly execute this command by calling system. I can just do system of cmd. That's it. It will create what you call. So cmd is to remove the directory. It will remove that particular directory. So any command can be executed just by calling system, but that is not expected. Okay, fine. Similarly, quitting from the Linux environment also simple. You have to just call this function exit of 0. And this env, I'm not giving the implementation, as I have already told. This anyway, this template was given. Only you have to write a for loop and you have to keep on display this. So en of 0 contains some environment parameters, en of 1 contains some environment parameters. So the last one will be having null. So as long as it is not equal to null, you should run a while loop or a for loop and to display the content of en. That's it. Okay. PWD is to print the current working directory. Already I have shown you the code to get the current working directory. So that is in the main function. Again, you have to use that here, get that and print it. That's it. And this is for history. So first, when history for implementing history, first you have to check what it is. I mean, history can be used in two ways. The user can give the history command something like this, history, that's it, or he can also give like this, history space some number. So you have to differentiate between the two. So how will you differentiate? In this case, if you see the length is 1, 2, 3, 4, 5, 6, 7. Sorry, in this case, in the simple case, the length is 7 plus 1, 8, including backslash n, it is 8. So the first thing you have to do is you have to check the length of the command. Okay. So you have to declare a variable int n is equal to string length of cmd. Okay. If cmd is equal to 8, if it is equal to 8, then it is first style of implementing history command. So then what you have to do? Just read the contents of history.txt and display it. That's all, nothing else. Else, if this is not the case, then it means that there is some argument. It means it's greater than 8. If it's greater than 8, then actually that part is tricky. So how will you do? Because from the end we want. If CMD5 means we need last 5 comments. We don't want first 5 comments. So how will you get the last 5 comments? So the logic is you can do anything, but I will give a simple logic. You declare a variable count, int count, okay, initialize it with 0 and run a while loop. And using this while loop, read every line from the, okay, read a line from history.txt. Read a line from history.txt. So this while loop, how long it will run? Until you have to keep reading until read not equal to null. You have to keep reading from history.txt until read not equal to null. So until read is not equal to null, read line by line. Read the first line, then next line, so on and so forth, and keep incrementing the count. So when you do this, when this while loop is over, no, in the count you will have the number of lines in the file. Okay, you'll have the number of lines in the file, right? But now the file pointer would have come to the end of the file. So you have to rewind the file pointer. There is some command available in C to rewind the file pointer. You have to check out. So rewind the file pointer using that command. Rewind the file pointer. When you rewind, file pointer will point to the beginning. Okay. Now we know how many lines. If you know how many lines, then you can easily figure out from which line I want to display. Then once again use a while loop. Once again use a while loop, and once again what you call use some other count. Okay, say count 2 is initially initialized with 0, and again read from the file until not equal to null, and uh, then increment count 2. Okay, and then increment count 2. So see, this number also you have to take. Say for example, if it is history 5, if it is history 5, then you can declare some n is equal to CNT is number of lines, CNT minus n1. Say n1 is 5 in our case. If it is history 5, I'm assuming n1 is equal to 5. If the command is history 5, okay, then here I'm assuming n1 is equal to 5. So that this n1 you have to fetch first. You have to remove from the command. You have to convert it to integer and you have to store it in n1. So now n contains from which line we want to display. Okay. So keep incrementing count 2, and then after incrementing count 2, check if what you call count 2 is equal to n. In that case alone you display that line. Otherwise don't display. Otherwise just read but don't display. So here also you should read the line. That's the logic. I think you can understand. So let me show this partial execution. So this is the prompt. Okay, so this is the prompt. Now I can give here command ls hyphen l. It won't work. It's a implementation pending. So what are the other commands? Clear I can give clear. Okay, and then pwd is not implemented. Anything else it will say implementation pending. Okay, then history. So exit I can give. Quit or quit, I don't know. Quit, yeah, quit, fine. So this is the whole story. I also have the full version of the program, but I'll not show you now. I'll execute it. So that is dot slash shell. Here I can execute all commands. ls hyphen l. Okay, so you can see it's displaying everything in the same style. And what else? Yeah, mkdir there also I could have done. I have not did that. So mkdir say I'm creating new directory n underscore directory. Created cd n underscore directory. Cd dot dot, it will go to the previous directory, right? So like this I can execute all the commands. History, okay, history 8, it will give the last 8 commands. So the last command you can see history 8, so that's the recent one, and then history from this, right? So that's it. Okay, so if you have any doubts or any clarifications you can ask, otherwise we can close the session. Okay, fine, then thank you. Your submission date will be Saturday night or Sunday morning. Okay, I'll be updating in the LMS historian. It's as usual. See, the complicated part is only ls hyphen l. Okay, other things are, I don't think it's not challenging. Only that is the challenging part. So what I suggest is first do the other parts. At last you go for ls hyphen l. one day if you sit for 1 or 2 hours, you can complete the rest of the part. Okay, so first don't go with ls-l because it may drain your energy. First complete the other parts, then go for ls-l. Yeah, Ritvik, I'll be sharing all the things, this recording and everything will be uploading in the LMS. Okay.